Hi, this is Pete with Phylum. Today we're going to go through a demo of the Phylum Web UI, looking at an example project. First, we can start with the dashboard, and at the top we can see Phylum's daily open source monitor. So in the last 24 hours, the system has identified 78 malware packages, and those came from 3,730 new packages that were released and subsequently analyzed by Phylum, and those comprised just under 300,000 files in those packages. On the bottom, we can see some of the new research that the team has put out related to supply chain attack. If we jump over to a project, here we're looking at Showcase 3. This is a Git project that might live in GitHub or GitLab. In this project, we only have 13 dependencies, and this is artificially small so we can go through it fairly rapidly. The ecosystems used here are Maven from Java, NPM from JavaScript, NuGet from C#, and PyPy from Python. One of the first things to note is for each of the dependencies we have in this project, Phylum creates something called a package score. This is kind of like a credit score for packages where we want it to be high. So it's between 1 and 100. In this case, we have a score of 5, which is really bad. And the reason we have a score of 5 is because this is a piece of malware. This package uses a pre-install hook in NPM to execute some commands as the user installing the package. In this case, we're identifying something that's taking the passwd file and some hostname information, the operating system, and shipping this off to a host on the internet. So this is pretty terrible. We don't want this in our project. But that package score generated for each of these dependencies allows us to bubble up a total project score by combining those values. And here we can see at a project level a relative score for how Phylum has identified issues in this software project. If the score was 100, we'd see a nice green pentagon in this radial diagram. This kind of shows us the soft spots or what really got hit in the project based on the score values. So we can see that license, vulnerability, malicious code, and author domains got hit pretty hard in this project. Next, looking through some of the issues, we can see the risk types on the left where we show each of the 5 domains that Phylum analyzes supply chain risk through. Similar to SCA products, we can catalog vulnerabilities for the packages in the system and also identify license issues if there's a commercial license risk to using one of the packages in the lock files. But our bread and butter is identifying supply chain attacks from malicious code and author risk. We looked first through this package before, but we can see a couple others that are fairly similar. In some cases, this is just trying to open a reverse shell to a host on the internet, right? This is pretty terrible. In another case, we can see that we actually have a typo squatted package in our lock file. So typo squatting is an attack where the attacker might find a very popular package like request, and they host a package with a very similar name, waiting for someone to make a mistake, type the wrong name, maybe misremember how to spell something. And if they do that when they're trying to install the software, they'll actually step on the typo squat package and install that instead. And this is a unfortunately very popular attack, partially because it's costless to mount as an attacker. You simply find a really popular package based on download count, and then you can spray names around that package as typo squats to try to catch a developer that makes a single mistake. Phylum identifies this automatically and can prevent you from accidentally installing typo squat packages. Jumping over to author risk. In this case, we're using a package anywhere auth version 1.0.2 that has been authored by and someone who's previously released malware. And Phylum tracks this. So every time we can track back an author to who influenced the package of its creation, we're able to then see what other packages do they touch, when do they enter a commit graph for another package, and alert our users that this actor has done something bad in the ecosystem before and you should probably stay away from them. One of the elements of Phylum that is pretty interesting is the ability to enable policy decisions to fine-tune how you want to interact with the data that Phylum identifies in the supply chain. Jumping over the Preferences tab, we have a default policy applied to the project, and this policy is actually backed by Open Policy Agent's Rego language. So here in the help file, we can kind of see how this works, and it describes how you might want to write a policy and develop your own. And then in the actual project, we can upload a custom policy that allows us to fine-tune how we interact with or act on the data that Phylum identifies for this project. So if we don't want to alert on certain types of issues or at certain severities or with certain properties, we can write that into the Rego language and then upload this policy to then fine-tune that data.